Welcome to the inaugural episode of Small But Mighty. Security might be a big subject, but that doesn't mean people can't learn a lot about security in a short amount of time. We know people are busy, but they're still hungry for ways to approach securing their organizations. And so twice each month, we're going to be hosting coffee chats with innovators and thought leaders in the cybersecurity space to provide big insights in a bite-sized format. Today, we are here with Justin Schneck, a software engineer at Very. Hey, Justin, tell us a little bit about yourself and what you've been working on lately.
Hi. I've been working with IoT devices for quite some time now. I sort of become obsessed with them a long time ago. Early on, I was a mobile developer, but then I decided that I wanted to be able to connect that together with some things that I love to do, like motorcycling. I had this idea to build a system that I could remote start my motorcycle from my phone, and found that there was a lot of complexity in connecting all those pieces together and making sure that you can communicate effectively with cloud devices and mobile phones. So I've spent the last 8 years or so building, co-authoring a framework for building IoT devices called Nerves. And today we have plenty of companies that are launching products on our platform and deploying them out into the field with Nerves Hub, our
Are any of them remote
system.
start motorcycles?
I actually, things amazingly come full circle. When you write a system that helps you build the thing that you dreamed to make a reality, you get so invested in building the thing that helps you build that product that you kind of put that to the side just long enough that you find somebody out there that goes, hey, look what I'm doing. And you're like, that's so cool. I wanted to do that. So yes, there is somebody who's working on that. There's a Japanese colleague that we have that's working on that.
Well,
right
then
now.
That dream will shortly become a reality.
Yes, yeah, and it's so great because I could facilitate that coming to existence.
Well, that's interesting. And I'm definitely going to come back to our remote start motorcycle at the end of our conversation. But today, I know we wanted to talk a little bit about how we can secure over-the-air firmware updates for IoT devices. So to start with, could you tell us a little bit about why this particular topic is so important and who might need to be worried about it?
Sure, security is something that is always on our mind when it comes to how we protect ourselves. And unfortunately, it becomes a little bit more vague, or I should say a little less personal feeling when it comes to the things that we don't see, like the digital space in our lives that connects our devices to the cloud and to services and providers. And we need it there more than anything because the exposure that these devices have. And when we talk about security, we should clarify that there's 2 aspects of this that we can talk about: physical security of a device, like that means that somebody has physical access to it, or digital security of the device, and that would be like communicating with servers and external systems. We're not going to get into physical security at all. I mean, if you can have physical access to a device, that's complex, protecting that. But digitally, yeah, that space, it's really important because there's, over time, software, it's malleable, and it's running out there in the wild. And every day you'll notice there's updates for things like your phone or your laptop or computers like those that are highly connected and available. And that's security fixes that were identified and patched. And it's important that those fixes get applied to these devices so that we can all move forward and stay protected. But it's a whole nother problem when it comes to how to maintain those in the wild for these boxes that might be installed, in a shed in the middle of a field that runs a power setup, or maybe helps operate some farm equipment for sensors or readings and things like that.
And I would imagine most of these devices
yeah.
are unmanned, right? So you don't have the person that's saying, remind me to put this update on later. You have to do it automatically.
Yeah, exactly. And that's a really good point, actually, because when it comes to the securing of these devices, yeah, the human, like when an update comes into your computer, you authorize that action, right? But these IoT things, there's no humans that operate them. They're supposed to operate on their own. And so how do you protect secrets on these things, these tiny little computers?
Right.
And so there's best practices, ways to be able to go about this that unfortunately have a higher bar to entry. It's just more difficult to be able to do this kind of programming. And so oftentimes you'll find that like young developers or people who aren't really versed in the security vulnerabilities that can be created or opened, if you were not to embrace best practices, they can naively put these into play and make it easy for somebody to be able to go in and get into devices. Most common one is shared credentials, right? So we always hear about situations where routers, you buy a home router for your home and you go and install it. And for a long time there, they would come with, oh yeah, you logged into the home router, username admin, password is password, and no one would change it. Right?
Yep.
So then everybody knows how to be able to get into everybody else's router if they have access to some sort of part of the network, right? And then the interesting part about that is California passed a law around 2018 or so that bans that from being able to be sold, those devices from being able to be sold. So they changed it. But there's another step now. There's another law that came about that protects against keys. They would go, okay, I won't put a known password on it, but I'll put this cryptography key just on the device, and it'll be the same one on every device. Well, then that was just a workaround to the same problem, right? So anyways,
if you know one, you know them all.
Exactly. You want to minimize the blast radius if something were to happen, if somebody were to compromise one of these devices, because really security is not a binary thing. It's like how secure you are versus, in the case of IoT device security. So all of this then to say, like, the crux of this problem, how do you protect secrets on a device that has no human to be able to like internally log in, like type a password in, like, and so those that answer commonly is found by using what's known as a crypto authentication processor. So it's this chip they put on the board, and that chip, when you manufacture the device, you say, here, you create a key inside of yourself, create some secret, and then give me part of it that's public, that's not the private one. It's known as public-private keys, right? So give me the public one so that I can verify that anything you tell me is accurate.
Right.
But I'll never see the secret that exists inside of you. So these processors are popular and often requirements in modern day systems. Like anytime you have an Apple device that participates in HomeKit, for example, that does that interactive home mechanism, requires to have one of these crypto authentication processors. And so that's like the best practice way that we can at least get started in protecting the communication that devices have with the outside world.
That's interesting. And if you actually think about it, it's security using hardware to create a root of trust, essentially, is security in two directions, right? Not only am I stopping you from getting onto the IoT device that's out in the world, out in the field, but also I, as the central location collecting data from that device, can be 100% assured that that data is coming from the real device and not from someone in the middle trying to feed me fake information. This is really interesting. It came up in another interview we did with an IoT specialist over at HP. So we talked about something similar using hardware to create that root of trust in IoT.
Yeah, that's the referred to commonly as client-side SSL in public key infrastructure. It's just like an additional step that happens on what we're used to today when visiting websites that are like HTTPS. That's server-side SSL. That lets you trust that you're going to the site that they claim to be. And then, yes, the second step is then that the server would ask you for your certificate, the client, and validate that you are who you say that you are.
Right.
That would mean that the client just holds a certificate as well. And those are the certificates that get buried inside of that crypto authentication processor.
Very interesting. And so then how does this apply to applying firmware updates over time? Like, how do you typically see this now used in the use case that we're talking about?
So firmware updates are secured in that case by means of allowing the server, the firmware update server, to verify that the person who's requesting the firmware is can validate that they're who they say they are. That's the device that they expect it to be. And then when you apply those, you can even use part of that key to be able to sign the updates that go through. So you can even encrypt the updates themselves and go extra levels of security to be able to make sure that in those cases, the software that goes across the wire can't be inspected because it's protected by the SSL certificates that you're also handing back and forth. And so your communication with the outside world is protected. And then also the contents of the disk that you have locally can be protected with disk encryption using a similar key signing mechanism as well. So that way, physical access, as a brief touch point, can rest a little bit more assured by encrypting.
Yeah, you don't need a lock and key as much.
Yeah.
Great.
Now, all of these are just steps to just obfuscate things and make it much more difficult for somebody to make you out to be a target. It's very important to be able to at least take these steps because you're not going to be easy prey at that point then.
Right. And so how then can we be ensured that updates are being applied reliably, right? So if there's not a human interacting with the device to make sure that the update happened and then use it, what mechanisms do you usually see to put in place to make sure that those items are actually being applied and like patches or anything else that's coming across over the air is working correctly?
Well, everything is digitally signed so we can checksum all of it at the top layer. But more importantly, when we apply updates, it's important that we have that we treat these systems a little bit with a little bit more of a special case, right? When you update your computer, usually you'll download the files and then you'll just apply them on top of itself, and then you'll reboot and things will magically work. And sometimes if you have a bad day, they won't. You'll just recover from a backup, but that's fine because you're a human and you were there to fix that problem.
Right.
But if you deploy an update to a device that, as we've talked about, would exist in a shed in the middle of nowhere, that's a weather station, and that device has a bad experience applying that update, or that update wasn't necessarily tested for that specific model of device, and it was accidentally deployed to the field, then in those situations, you need to be able to have like some serious contingency plans in place. With Nerves, we institute what's known as a BlueGreen deployment mechanism on board. This term comes from the web world, and really it's just A/B partitions.
Okay.
And so we have like a slots system where you have an A slot and a B slot for firmware that goes in. And when we stream firmware, we stream the entire thing as an entire package, the entire operating system and application all at once into the slot that's not currently booted. So if you're booted on A, we'll stream it into B. And then what happens is we say, okay, now we're done streaming into the B slot, switch, reboot into B. And if you fail to boot into B, you have a last known good working firmware to fail back to. So you can try again, or not become the dreaded brick,
right?
The smart brick.
Yeah.
Which is still just a brick.
Yeah.
Right. Justin, I was going to ask that, is there some sort of retransmission capability built in there? So if you're sending the update, you sense a failure and it's not happening, this all automatic, this A/B swapping sort of thing?
Yeah, in our systems, we have them designed for a lot of the industrial platforms to be able to do some more of an automatic failback approach. We do support some DIY maker hardware like Raspberry Pi systems that currently in those cases don't out of the box, but we're working to add that support as well. Now our OS will run on mostly anything that'll support embedded Linux, and so it's not just like the Raspberry Pis and things of that nature, or what we offer currently as far as base like devices we support. But building that feature in is not terribly difficult to do, and we're starting to work documenting how to do that on additional custom systems.
Gotcha.
And so the alternative to what we're talking about today, so what might be happening if they don't have a system in place like what you're talking about, is people might just be leaving devices without updates in the field, right? Is that pretty much what's happening if they don't have something like this set up?
Yeah, and there's a lot of reasons that just happens because the biggest problem is that lots of these IoT devices need to have remote data links, and the easiest thing to reach for is, oh, I'll just put a cellular modem on it and call it a day. But connecting to a cellular network can be expensive. And it's funny that, because I say that, but as a consumer, I go like, oh, $50 a month, I can get like unlimited data on whatever mobile network in the United States. And I can stream whatever I need to all month long and never worry about my data usage. And then we have global SIM network providers, like there's a handful of them out there, but the rates are on average costing, let's see, 20 megabytes, which is not a lot of data. You know, it's the size of like maybe a handful of pictures. Is streaming that to a device cost about like $15, $20 or so on a lot of these popular networks. If you were to just sign up and be a nobody, you know, and not sending, like, you just sign up for service. And so if I were to update an entire system, like a big OS system, like, you know, you think of like Ubuntu or desktop systems, Windows, Mac OS, these updates are like hundreds of megabytes. Now, you know, when it comes to our software, we try to promote really lean ones. So we're trying to be able to say like whole OS and everything, like 20, 30 megabytes. But even still, if you push 30 megabytes, that's being like $15 like USD. Like, that's a lot of money to put out an update. So the businesses are not being incentivized to keep these devices up to date. Either big telecom was not ready to bring on all of these devices at once, or they're just completely corrupt. And they're not providing the right business case to be able to keep consumers' devices secure. I mean, people are more incentivized to stream movies like Sharknado on Netflix for hours at a time for $50 a month in their data plan to stream gigabytes of data than it is to be able to keep some of our most important devices that are out in the field up to date and secure.
Wow.
Right. It sounds like the business models are not quite suited for devices. Especially, you know, you talk about the expense, but then with the volume of data, but then there's the breadth of all the sensors, right? That was just one sensor, and you multiply it times hundreds, and then it gets really expensive. So.
And I could feel for them. If you're a telecom company and you're onboarding like thousands of new SIM numbers and devices, these towers reach a certain capacity, just like, you know, we see Wi-Fi equipment in our homes start to slow down the more devices show up. Or, you know, if you've ever been in a public place where there just is lots of phones around you, your service ends up suffering just because of all of the noise in the area. That's the same situation now.
So is the answer to, you know, set up your own private LTE network or something like that? I mean, I imagine you can only do that if you're of a certain size and have the, you know, the wherewithal to be able to execute something like that. But is that the only answer that people have, or?
There's a couple ways to approach it. For one, with Nerves Hub, our firmware device management and firmware update network for Nerves, we are applying some additional features to it to help alleviate this problem, at least on expensive connections. For one, we're allowing you to then like resume download of a firmware. So if you request a firmware update from a server and the server starts to download updates and you're on a cellular link, and let's say the tower kicks you off for a brief moment and you come back online, that you don't have to stop and then start over. You can resume with minimum bit loss, so that those expensive bits are not lost. They're saved on the device. And then next step to take is to do something a little bit more extreme, which is to be able to support, we're adding support for binary delta firmware updates, like so patched updates. And the way that this works is the server itself will know what version of firmware is on your device currently, and will know what version of firmware we're trying to send to your device. And on the server, what we'll do is we'll capture the differences in all of the bits between the two systems in the most efficient way possible to create just the content that changed as a binary representation, and send only that down the wire to the other end. And because we implement from the start this A/B partition strategy, we know that on the other partition, when we stream in and you try to, and once you stream into there, that we can balance the two by writing the patch and then having the patch pull the data that it needs from the other side to populate itself, to fill in the gaps.
Right.
And then once that happens, because the original files that have then been reconstituted on the other end are digitally signed, we can check all their signatures and make sure that they were appropriately rehydrated in a way. And so that can save a considerable amount of data.
Right. So it's essentially finding a way to make the process as efficient as possible is the best solution here for the time.
Yeah, and also, LTE might not be the answer for you. You might not need that long range solution. And there's other options available like LoRaWAN or long range radio, or Wi-Fi mesh is even becoming popular as well if you need to span long distances.
Yeah, I even heard that satellite providers are now very big into IoT, using their bandwidth for that, given their coverage, et cetera.
Yeah, we'll all hopefully be able to play with Starlink soon, right?
We can dream. Well, that is all the time that we have for today. It's been really great grabbing you for this 15-minute block and really pulling a ton of information out of your brain in such a short amount of time. But I do hear that you are quite the coffee connoisseur, so no coffee chat would be complete without discussing some important opinions about coffee. So do you have a recommendation as we part for all of our watchers that may be interested in a good coffee?
Sure. Well, today I'm drinking Abracadabra Coffee Company Cold Brew from Vermont. It's a nice roaster that I found in my area, we're close by. They've been really nice in shipping out during this time. But when it comes to brewing coffee, I was at the end of last year, I ended up spending some time in Japan, and I had the pleasure of being introduced to what I believe is the most scientifically accurate, or I should say consistent. It can produce the most consistent cup of coffee, the siphon brewing method. And that, anyways, to break it down, immersion style brewing techniques like using a siphon or an AeroPress are far superior to drip style coffee techniques like pour over or drip systems. As far as minimizing the amount of variables that go into coffee, producing a cup of coffee, the siphon controls the most of them, and it will give you a very consistent cup. Now you can still do it wrong.
Like with anything.
So you can, yeah. But at least you'll have a consistently bad cup of coffee then.
There you go.
At least you know what you're getting.
Yes.
Right.
Well, so I know what my Amazon shopping list is going to include next. I've been on the quarantine everything from Amazon, so they probably are wondering what I'm buying next. But now
Direct
I know
from Japan.
Yeah. Awesome. Well, thank you so much for your time, Justin. We appreciate it, and we'll talk soon.
Thank you.
Bye.
Thanks, Justin.